Evaluate this integral sine squared theta from 0 to pi. So we use the following result, namely sine squared of an angle, say sine squared x, is equal to 1 minus cosine of 2 times that angle divided by 2. So if we apply this here, we get 1 minus cosine of 2 times the angle 2 theta, right, over 2 divide d theta. Now we can take the half outside since it's a constant, so we get a half 0 to pi 1 minus cosine of theta 2 theta d theta. And now it's a matter of finding the antiderivative and then evaluating. So the antiderivative of 1 is just theta. The antiderivative of cosine is sine 2 theta. But of course, if we differentiate this, we'll get that 2. So to cancel that 2, we have to multiply by a half. And then we have to evaluate this from 0 to pi. So I'll write this on the next page just to make it clearer, since I've run out of space. So theta minus sine 2 theta over 2 evaluated from 0 to pi. And now we just substitute the upper limit of integration. We subtract that from the substitution of the lower limit of integration as follows. So it's a half pi minus sine of 2 pi over 2 here. Then we subtract it from the lower limit of integration, 0 minus sine 2 times 0, 0 over 2. And now we notice that for the second term, everything will be 0 since sine of 0 is 0. So this whole thing is 0. And of course sine of 2 pi, since sine represents the y value in a unit circle. So 2 pi will just be 0. And then we just left with pi. So it's pi over 2 is the final answer.